So in this portion here, we're going to do the remaining two questions for this test portion, okay? 2E. Those are 2 and 4. So let us start with 2 here. Question number 2. This you'll find on textbook, page 119. Okay. Let us listen to the question. Here it says, Joseph jogs from end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds and then turns around and jogs 100 meters back to the point C in another 1 minute. Okay, what are Joseph's average speeds and velocities in jogging? A from A to B. So let us do that first. So Joseph jogs from one end starting point A to B, covering, this is a straight line road. So he's going through a straight line motion, 300 meters. Then he turns back and comes to this position C in another 1 minute, covering 100 meters. Okay, 100 meters. So let's just do slowly and thinking. It's quite easy if you do that. Okay, so here, let's take the first case. We have to find the average speed and velocities in jogging from A to B. So let's write here from A to B. Okay, just keep it simple and just think a lot as you do it. It becomes quite easy when we do that. Okay, so here, from A to B, total distance that is covered will be how much do you think? Okay, total distance. Okay, let's just write the whole thing. Covered by Joseph in going from A to B. Yeah, simple common sense, that is AB, right? From here, starting, ending here. So that is 300 meters, his total distance, right? Then how about his total time taken then? Total time taken for this, okay? Total time taken will be equal to, let's go back to question. Joseph jogs from one end A to the other end B on a straight 300-meter road in 2 minutes 30 seconds. So for him to go from A to B, he took 2 minutes 30 seconds, very clearly given to us, right? Now we need to change this minute to the second, which is the SI unit, because we're going to use SI unit primarily, right? For which we already know hour, 1 hour, 60 minutes, and 1 minute, 60 seconds. We know this. So if you want to change this minute to second, we need to multiply by 60 seconds plus 30 seconds, which is equal to 2 6 are 12. So 120 plus 30, which is simply 150 seconds is his total time from jogging from A to B. Okay, so therefore we know from our previous classes that his average speed, or average speed you can say, Joseph's average speed will be, when it is average, we always use total distance covered divided by total time taken by him to cover that same distance, right? So having done this, we can write here total distance is 300 meters divided by, what is this? 150 seconds time, total time taken. So if you shift this power is +1, even though it's not written. So if you shift it to the numerator, this s to the power +1 will become s to the power -1. So we may as well do it here itself. Okay, then 0, 0 cancel, 15 2s are 30. So his average speed is 2 meters per second. First answer. Okay. Then how about his average velocity? For velocity, the difference between speed and velocity is, instead of total distance, we need total displacement. So let us write here total displacement. Total displacement is what? Let us see into the question. Now the definition for displacement, yeah, can you say? Yes, the shortest distance between the initial and the final position of Joseph. So initial position is A, and he ended up at B, as you can see here, A to B. So the shortest distance between any 2 points is the straight line, which is AB, right? So we write here AB, which is equal to, or we can write here 300 meter. So in this case, total distance covered and total displacement are same, 300, 300. So therefore, his average velocity will be equal to, only difference is the formula, total displacement, his total displacement divided by time, total time taken. Total time taken by him. Now total displacement just now we got 300 and then meter on the numerator. Time taken will be the same, right? So 150 and second go up minus 1. So 0, 0, 15 2s are 30. So in this case, from jogging from A to B, his average speed and average velocity are the same, 2 meters per second. Now let us do from A to C, second A to C. Go to B on your question, you look there. Now we have to find the same thing, average speed and velocity, when he jogged from A to B, then came back to C. So let us do that. Same process will follow. Total distance covered this time will be, he went from here to here, that's correct, AB, plus he came back to C, so BC. That's the only difference. So AB 300 plus BC 100 meter, back he came. So the total displacement will be this time 400 meter. Total time taken also 2 minutes 30 seconds from here to here. But for him to go from here to here, textbook said there was additional 1 minute. Look there in your text. There you see 1 minute. Yes, that's right. So we will just need to add here 1 minute. And we just need to add here this 1 into 60 seconds. That's the only difference. Then just need to make a slight adjustment, otherwise the rest is same. So 120 plus 30, 150. We know that from the previous case. 1 into 60, 60 plus 150 is 210 seconds. Now the time is more because he's jogging back from B to C, right? So his average speed formula will be same in the second case also. Only thing is the number values will change, which is total distance. This time is not 300, 400 meter. And 210 seconds will go up. Minus 1, you can see here. So this is just a case of another value for the answer. Otherwise, the process is the same. So let us see here now. 0, 0 cancel. Then 40 is divided by 21. Ones are 21. So 9 in hand. 3 minus 2, 1. 0.0. Okay, 9 ones are 9, 9 twos are 18, 1 in hand. Then point means we can put here 0, right? We can put here 0. So let us say here there is 190, 189, here 1, so point, then 0. Still lesser than 21, so put here 0 and then 0. 5 will go, I think 5 ones are 5, no, 4. 5 is too much, so 4 will go. 4 ones are 4, 4 twos are 8. You can stop there once you reach the third place of decimal. So we write here 1.904 meter per second, which is simply 1.9. Third place is less than 5, then this won't change. 1.90 meter per second approximately. Right? So that's your answer for the second case, A to C, average speed. Now his total displacement this time. Look here, his starting point is A. And his final point is C, as you can clearly see here, C. So the shortest distance between the initial and final point is called displacement. And the shortest distance between 2 points, you know, is a straight line, which is AC. So instead of AB, this time the displacement is AC. So this is AC. Now AC is nothing but, if you will patiently look here, AC, this distance is, you can express in another way, AB minus BC, then you will get this portion AC. So we can put the BC. So AB is 300 meter minus BC is 100 meter. So that will be equal to 200 meter. Right? So displacement this time is 200 meter. So his average velocity will be same formula. This time only the value will change. So we'll write here total displacement. Just now we got 200 meter by total time taken is here. See, 210 seconds. So we write the 210 second coming up minus 1. Then we will be getting here 0, 0 cancelled. So 20 is divided by a bigger number. In such a case, we know we have to put 0 point to make 0 here, otherwise it won't go, right? So 21 9s are, 9 1s are 9, 9 2s are 18. 10 minus 9, 1, 9 minus 8, 1. And already borrowed, so gone. Then point means 0, I can put here. 5 1s are 5, 5 2s are 10. 5 remainder, 0. Point means I can put here 0. 21 2s are 42. We can stop there, we have reached the third place. So our answer is 0.952 meter per second, which will be approximately 0.9. Third place is less than 5, means this won't change, 5 will remain like that, meter per second. Okay, so that's our answer. So that is question number 2. One more question to end up this test portion 2E. 2 questions were done. Question number 5 and 1 were done in the previous class, right? After that you can take your test. Okay, so let us go and do that. So question number 4, page 119. There you will see here, question number 4, textbook, page 119. Okay, let's read the question. A motorboat starting from rest on a leg accelerates in a straight line at a constant rate of 3 meters per second square for 8 seconds. So let's just write that down, because we can get a lot of information from there, right? The particular motorboat, okay, starting from rest. So this is an important word here, a key word, right? From rest on a leg accelerates. So accelerates here means it is gradually moving faster from slow rest to becoming more and more faster. So positive acceleration, therefore. As we have been saying again and again, when an object slows down, like application of brakes by a car, it is called negative acceleration. And if car is picking up slowly and then increasing its speed, that's called positive acceleration. Okay, so accelerates in a straight line. In a straight line at a constant rate, at a constant rate. Here means constant rate means increasing at increasing velocity. Rate is called this is velocity. Okay, rate, increasing rate of 3 meter per second square. So this is another important information for 8 seconds. For 8 seconds. So this is another important information. So there are 3 keywords here. So let us write them down one by one. Here, rest means initially the boat was not moving, so initial velocity is 0 meter per second. So that's your initial velocity. Then accelerates at constant rate of this one. What is this? The answer will be, look at the unit. We know on our previous class, meter per second square is the SI unit of acceleration. It's not velocity, okay? Velocity is meter per second. SI unit of acceleration is meter per second square. So even if the question did not tell us this is acceleration, we know because the unit is that of acceleration, right? So acceleration is 3.0 or 3. That means meter per second square. As you can see here, velocity is meter per second, but this is per second square, so this is clearly the acceleration of the boat. Then for 8 seconds means anybody can understand that it's talking about time. So the time taken by the boat is 8 seconds. So we have this information. What is the question asking us? How far does the boat travel during this time? So how far does the boat travel means that is distance S. Distance traveled. If you want to write. That's what the question is asking. Only the thing that they're asking is that one. This shouldn't be hard. By now we are accustomed to this, so let us do it. So here we know the formula for S we can use is ut plus half at square, because everything is there. U is there, as you can see, A is there, T is there, see, U, A, T, everything. So we can just replace those values. U is 0 meter per second into T is 8 seconds. 8.0 means 8 only, okay? We can write 8. Plus half into A. A is here, as you can see, 3. So I'll just write here 3 meter per second square. If you bring the second square minus down, it will become plus 2 power into means you can use the normal multiplication sign also, like this, or like this dot also is allowed. So T is 8 seconds, so T square will be 8 into 8 and second into second, therefore second square. These two will immediately cancel, right? And this portion will disappear because it's multiplied by 0. Then 2 1s are 2, you can cancel. Then 2 4s are 8. 4 8s are 32, and multiplied to 3 is your answer. Then 3 2s are 6, 3 3s are 9. So here 96, and the only unit left uncancelled is this, so meter. So therefore, distance traveled by this boat, in short you can write distance traveled S is equal to nothing but, in 8 seconds it is traveling 96 meter. Okay, that concludes your portion for this test. Now you can go and give the test. As I said, every test is identical to the questions that we have solved. Only thing is slight change in the number. And if you do those tests, it will really make things easy for you, and you will understand it so well. Okay.